Hi, everybody. I'm gonna let this sit for a little bit so we can accumulate questions. I got 2 from students in my email, and 1 just got posted. So I'm gonna wait about 5 more minutes or so, and then we'll just go through them all. So just keep the questions coming as you come up with them. Okay? See you in a bit. Alright, let's get started here. We'll just wind this down. I don't know what it is about Nintendo products, but they have, like, the best interstitial music. Like, if you had a Wii, you know that the Wii Shop tune is the best tune. Alright, I'm just gonna start at the top here, and we'll work our way down. Oh, I think Maya's here. So, there's been a development with Maya. And that development is that I felt bad all quarter shooing her out of the room, so yesterday I went and bought her a pet bed. And I put it outside the room, so now she's sitting in it and staring at me and meowing. Do you like the pet bed? She's just being quiet, so Maya's very happy, but she might not actually make it into the room because between the door and me is this bed that she just keeps getting cat trapped in. Alright, so let me write this out really quickly. What are we mixing here? This and this. Alright, so I'm going to just go through the questions I was emailed first, since it's easier if I just go top to bottom here. And so the question that was asked by a student was, if 138.4 grams of KBr and 58.8 grams of copper sulfate are combined, how much of this gets made? Shh. Sorry, I can hear my cat meowing out of the corner of my ear. Maybe I had to move the bed further away. So, since I give you 2 reactants here, this is a limiting reactant problem. So we're going to have to solve the problem to figure out how much K2SO4 is made for both. Maya, stop. I don't want to squirt bottle her when she's in her bed, but I might move the bed. We got to figure out how much K2SO4 is made in both cases, and the one that makes less is the limiting reactant. Well, we could just ignore CBr2. We don't care about that. But the first thing we actually have to do is we have to balance the equation. So this equation isn't balanced because I have 1 potassium over here and I have 2 over here. So I got to do something like this. And that should solve it. So 2 potassium, 2 bromine, 1 copper, and a sulfate. Yeah, that looks good. Okay, so let's do the calculation. So we're going to go grams of whatever we're starting with. I'm just going to call that grams of X. We're going to turn that to moles. Then we'll turn that into moles of K2SO4. And then we can turn that into grams of K2SO4. But as long as we're at this point, we can then determine the limiting reactant. And then continue the calculation. This is our goal, remember that. So let's start with this, 138.4 grams KBr. And then I'm going to turn that from grams of KBr into moles of KBr, which I'll then turn from moles of KBr into moles of K2SO4. And then I'm just going to do it this way. We're going to turn moles into grams here. Because why not, right? So these cancel out. These cancel out. These cancel out. We should get an answer in grams K2SO4. Now I got to go to Lentech. I got to go look up the molar masses of stuff. So let's do that. So Lentech. And I want, which ones do I want here? I can't see them because my screen is covered. So I want KBr. That's 119. So we'll write that down. So 1 mole of KBr, 119.00. And then I want K2SO4, which is 174.26. Oh, that's what's going on there. Okay, so 174.26. Okay. And then finally, I need the mole to mole ratio. So KBr to K2SO4 is 2 to 1. So we got to put a 2 there and a 1 there. All right, let's run it in the calculator. 138.4 times 1 times 1 times 174.26 divided by 119 times 2. And I get 101.334. Promises give your answer to 3 sig figs, so we'll do 101 grams of K2SO4. All right. Now what I want you to do, I've done 1 reactant. I want you to start with the second reactant with this. Do the stoichiometry for me. And tell me the number of grams of K2SO4 that you make. Okay? So I'm going to give you like 3 minutes to try that. Since it's a review session, you should do a little bit of review, right? As opposed to just me showing you how to do all these problems. So go ahead and do that. I'm going to wait for about 2 or 3 minutes, and then we'll go. I will do the problem. We'll see if it matches up with what you got. Okay? So I'll see you in a bit. All right, let's go over the answer here. So we're going to follow the same process here. And we'll turn moles of copper sulfate into moles of potassium sulfate. Oops, I didn't write moles there. And then finally, we'll turn moles of K2SO4 into grams of K2SO4. And then we'll check that our units cancel out, so those cancel out, those cancel out, those cancel out. And then we'll do the numbers. I'm going to look up here really quick. It's 1-to-1 ratio, so I'm just going to quickly go 1, 1, so I can scroll this down safely. This number has not changed since we used it up here. So I'll just copy it. But I do need to go look up what CuSO4 is, and I'm typing it somewhere else. Where am I typing? I don't know. All right, 159.61 is what my calculator gave me. And so I'm going to put all this in the calculator and punch it out to get 64.2 is what I got. All right, so those are my two answers. I'm going to underline them with I guess this is pink or magenta or something. I don't know. It's not quite red. I'm going to underline them with that color. Whatever it is, I can't tell. And the one that we make less of is what our result is, that means that copper sulfate was the limiting reactant. So this is our limiting reactant. This one was an excess, and when we do with excess, we just cross it out. Because we did not actually make that one. It was an excess. That would be what we would make if it was the limiting reactant itself. All right, any questions, let me know. I got to look up the lab questions here. Oh, I have like all the PDFs from yesterday. I need to... We do not need Chem 131 for this class. So close all. Oops, not control panel. I want computer. This is 140, and I want the lab number 5. Okay. So let me try and capture this real quick. Boop. Oh, nothing happened. There we go. So there's a question on the lab about question 2, 21, and 16. So let me try and find those. All right, so there's number 2 on the screen. Describe a situation where using a beaker or graduated cylinder would be more appropriate. Then describe a situation where using a pipette or volumetric flask would be more appropriate. So to answer this question, what I want you to do, I'm going to try and avoid just telling you the answer here. What is a beaker useful for, according to the directions in the lab? So, like, when you go back up here and read about a beaker, yes, you do have to read about the glassware. You want to figure out when you should be using a beaker for a number. And I'll give you a hint. Oh, maybe it doesn't talk about the glassware in this lab specifically. I'll give you a hint for that question. I must be thinking of a different lab. When would you use a beaker versus when would you use a burette or pipette? Well, depending on what you want to do and depending on the number of sig figs each piece of glassware uses. For example, a beaker only has like 1, maybe 2 sig figs, whereas a burette has at least 4. So why would you use a burette for certain things versus a beaker? Try and think of it from that perspective. 21 and 16. So if I scroll all the way down here. So the way that you do number 16, and I can't do number 16 without doing all the questions before it, is to find the number of moles of sodium hydroxide required to neutralize the vinegar sample. What you first have to do is find the molarity of sodium hydroxide, and you do that in this first part. So when you do step 13 here, you will get the molarity of the sodium hydroxide, which you're then going to use in question 16 and onward. And so if you know the molarity, you know the volume, and you do know the volume because that's what this is telling you right here. You know the number of moles that are used. So that's question 16. And then question 21 down here. For question 21, what you're going to do is... Let me actually put that one on the screen here. We can do one similar to this. Oops. So let me clear the screen here. This one I'll actually do. So instead, I don't want to just use the numbers that are given to you. I'm going to use... So NaOH. We'll use this. And then for our phosphoric acid, we'll use... I'll do that. And then its volume, we'll do 25 milliliters. All right, so now what we're going to do is we got to write the balanced equation for this. So let's do that. So sodium hydroxide, phosphoric acid, and these are going to react. Now, if you go through the lab, it will tell you how to do an acid-base neutralization, where you react the hydrogen with the hydroxide. And you'll make, the rest will be a salt. So I'm just going to write down the product here. And then we're going to balance the equation here. So I got 3 of these. And that's going to make 3 water. I believe that's right. Yeah. All right, so if I know the number of moles of this, then I can do moles of... Oops, sorry, wrong way. I know the number of moles of that. I can turn this into moles, and then I can turn this into a volume, right? So how do I get the number of moles of phosphoric acid? Well, I just multiply these two things together. So let's do that. So molarity times volume equals moles, which would be, for phosphoric acid, be that times the volume, and the volume in liters would be 0.025 liters. So these cancel out, and I would get a cat. Maya wants to say hi. Here you go. You can say hi. Wish them good luck on finals. Yep, there you go. Okay. One last Maya for you. I got times this on my calculator. 0.1 times 0.025. So I get... There you go. Actually, you know what? I'm going to go back up here and change this. I'm going to make this 4 sig figs just so everything is 4 sig figs. There we go. Okay, so... Al, what am I doing? This is not milliliters. This is supposed to be moles. Sorry, I was looking over here for some reason. All right, now that you know the number of moles of phosphoric acid, I could figure out the number of moles of this stuff by using the mole-to-mole ratio, right? So let's do that. So moles H3PO4, moles of NaOH. What's the ratio of these two things? Well, it's 1 to 3. Because I need 3 sodium hydroxides to react with 1 phosphoric acid. So that's how many moles of sodium hydroxide I have. And then the last thing I can do is I can turn molarity, or I'm sorry, moles into volume by using molarity. Right? So if I know the molarity of the sodium hydroxide solution, which I do, I wrote up here it was 0.1500. I can say, okay, moles NaOH per liter. Well, there are 0.1500, like we just said. So how many liters would it take to do the titration? And what I get is 0.05000 liters, or 50 milliliters. So that's how you do this type of problem. You want to always, for a titration problem, find the number of moles of the thing that you can. Because for one of these problems, you're going to be given both quantities. You want to find the number of moles of that thing, turn that into moles of the other thing, and then use that to determine whatever calculation you need. All right. While we're at that, I'm gonna skip the iron question really quickly just to answer this lab question. That's right below. Where's my cursor? I'm gonna do this one right here next. Just because I have this on the screen. So part A, finding the volumes for the experimental. So that's this right here, I believe, right? All right. So what number 8 is asking you to do is I want to make 100 milliliters of diluted solution. So what that means is that if I go M, oops, I got to do it this way. I want to make, if I make my little chart here, I want 100 milliliters of solution. And what I need to do is on the stock solution there, so I know that the stock solution is this, because it tells you. And then I want to do a dilution factor of some amount. So if my dilution factor was, say, 3 on there, then this molarity would be 0.8261 divided by 3 moles per liter, which equals... She's still meowing at me in the hallway. That. And so now you got to figure out what number goes in this. You can't see anything that I'm writing because it's all under this this thing here. So you want to solve for that volume. So that's the volume you're trying to solve for. And so you do this. Yeah, I can't type everything into the Google Sheet. So you do have to use this document. If you're only using the Google Sheet, you're going to get stuck because I can't type everything in there. It would be 75,000 pages long. All right, what's the next question I have? So let's do this one right here. I'm going to just highlight it in the chat. So what I want you to do is try and do this for yourself using that information. I'm going to give you like 4 or 5 minutes to try that problem that's highlighted in blue there. Well, now it's highlighted in gray. It'll be blue in a second, though. And then when I come back, I got to go get some more water because I just drank it all. When I come back, we'll go over how to set it up and do the problem, okay? So I'll try that, and we'll see you in a bit. Alright, I'm back. I don't know if that was enough time, but let me do this again. So let me write down the balanced equation here. Oh, it's... grab the pen and I grabbed the wrong end of it. Alright, and so we have 12.4 grams of iron. And 24.4 grams of sulfuric acid. We'll just do that. And so what mass is formed here? So we could do that. So going down to these questions that are down here in the chat. So asking about these two right here. So any reaction that gives you combine two substances and the numbers are given for both is a limiting reactant problem. Because one of those things will run out first. Now, what if I give you a problem that says excess? So that would be something like this. Where instead of giving you a number, I just say excess. What that means is that, oh, if it's an excess, you don't do that calculation, because we don't do excess calculations, right? But in this case, it's not in excess, so I can... Oh, history tool. I don't know why the history tool doesn't work and why I expect it to work. Because now I got to do this again. Layers. All right, so we'll do this problem now. We're going to turn grams of iron into moles of iron, which will then turn into moles of, what's our target? Iron sulfate. Looks like iron 3 sulfate here. And then we'll turn that in from moles into grams. All right, iron's easy. I don't even have to Lentech that. I have a periodic table right here. So 55.845. So we'll do that. Oh, I got to cancel out my units first before I do the numbers. Just to double check, make sure everything is lined up. Okay, now we can do this. Then I can look at the balanced equation. There's 2 iron for every 1 iron 3 sulfate. And then Fe2SO43 I got to look up on Lentech. So Fe2 parentheses SO4 parentheses 3. 399.88. That's a really heavy compound. There's a lot of stuff in that. Lots of irons and sulfates. Okay, so 12.4 times 399.88 divided by 55.845 times 2. And the result that I got was 44.4 grams iron 3 sulfate. All right, so let's do the next one. Which will then turn into moles. And then we'll turn that from moles into moles of iron 3 sulfate. Which will then turn into grams of Fe2SO4. 3, just like before. All right, so now we'll fill in the numbers here. So sulfuric acid to iron 3 sulfate is just 3 to 1. This number over here is the same as this number from before. So we can just fill that directly in. And then I just need to know the molar mass of sulfuric acid, which is... I gotta click on the thing. 98.08. And you can see that this is obviously going to be the limiting reactant because there's way bigger numbers on the dividing. 399.88. That's not what I meant to do. I messed that up. Divided by 98.08 times 3. 33.2. All right, that's the smaller number. So that's our answer because this is the limiting reactant. This one is an excess, and so we don't use it. All right, so the last question that was asked is 5B on Unit 15's worksheet. Let me find the worksheet real quick. Because then after I answer that, we'll take our break and see if we can get more questions. Five B. Is that gonna... Yeah, there we go. I just need to do this. All right, so how do we do this? So first of all, you have a limiting reactant problem at the start there. So we need to get the answer for 5A in order to do this. Now, in order to do that, I could just go get the answer off the answer key, but it's a review session, right? So let's review. So what I want you to try and do, we've done 2 of these today, so let's do one more. So tell me the mass of acetic acid that you can make from those amounts using that equation up there. Don't forget to balance it. I'll give you like 5 minutes to try that, or until I see an answer in the chat. And then I'll go over the answer, and then we'll talk about what to do with part B, because for part B, we need to figure out what to do with that from the answer for part A. There's actually 2 ways to go about it, and they're a little bit complicated. So I'll let you think on this for just a second. We'll go over the answer in just a bit. All right, 1 or 2 more minutes and we'll go over the answer to 5A. All right, let's go over the answer. So first thing we gotta do is we gotta balance the equation. So we have ethanol. We're gonna oxidize it, because of course we are. And we're gonna mix those together to get water. So let's see here. Do I do anything to it? It's all ones, right? So 2 carbon, 2 carbon, 3, 5, 6, 1, 4, 6, 1, 2, 3, 1, 2, 3. Yeah, there aren't any coefficients to put in here. Oh, as indicated by there's a blank and there's no blank in front of H2O. Maybe that's a typo. All right, so we've got 61.08 grams of oxygen. And we have 44.51 grams of ethanol. Sorry, I had to squirt bottle Maya because when she starts going, I'm just like, stop. So we'll turn this into moles. And then we'll turn this into moles of, what is it that we're looking for? We are looking for acetic acid. So we'll do this. And we'll turn that into grams of that. And then we'll cancel these out. And we'll get a mass. So let's do that. So 1 mole of oxygen is 32 grams. It's just whatever it is on the periodic table times 2. Acetic acid, I don't remember. We'll look that up. HC2H3O2. 60.05. And then the ratio here is 1 to 1. So how much can I make out of this? Would be 61.08, 60.05, 32. So I could make up to 114.6 grams of acetic acid if oxygen was the limiting reactant, which it might be. It could be. We don't know yet. So now we're going to go down to ethanol here. And we're going to turn that from moles into moles of acetic acid. And we'll turn that moles into grams of acetic acid. And then we'll just go and run all the numbers. So this is still 60.05 because it's the same as before. It should be a 1. This is 1 to 1 because all the coefficients in the equation are 1. And then, I don't know what ethanol is, so let's look that up. CH3CH2OH. 46.07. And then we'll punch in all the numbers. 44.51 times 1 times 1 times 60.05 divided by 46.07 times 1 times 1. And I get 58.02 grams of whatever this is, acetic acid. Okay. So that's my answer because it's the smaller one. So this is the limiting reactant and this is excess. Woo, we don't use this number. At least not for part A. Part B is why I tell you to just loosely cross these out instead of just obliterating your answer so that you can't see what it was. Because if you do that, then you sort of have to do the problem over again anyway for when you get to questions like part B. So part B is, what is the mass of the remaining excess reactant after the reaction has been completed? So how the hell do you do that? So I'm going to draw a picture here. All right. And so this part of the picture right here, it's going to be like a bar graph. So this is the amount of a vinegar made from the limiting reactant. And so this would be 58.02 grams right here. Now, this number right here in pink, that's supposed to go around the edge of it. I'm just not drawing it super well. This is the vinegar made from the other reactant, which would be the oxygen. And so this number would be 114.6 grams. So what we actually want to find the amount that would be made from just the excess reactant would be this right here, wouldn't it? Because if I can find out how much of the product was made by using only the excess oxygen, I could then calculate and go back to figure out how much excess oxygen there is, right? So what that means is that if I subtract these two numbers, and this 2 is just not going to get kept because of how sig figs are going to work here. We can get that many grams of vinegar if we use the excess oxygen and then reacted it with further ethanol. So now you have a new problem that you can do where you could take this number and you put it back into the equation and you say, okay, well now I have Was it 56.6? Yeah. Yeah. I have... Oops, sorry, that's not where that goes. I have this many grams of acetic acid. I want to figure out how much of this is needed to make that. All right. So now what I'm going to do is we're going to just clear most of this. We're going to go whoop. Oops. Well, actually, I guess I could get rid of that too. So we're going to go boop, boop. And hopefully that'll still be there at the top. Okay, cool. So we're going to do 56.6 grams of acetic acid, which I will turn into moles of acetic acid. Give me just a second here. Getting pinged like crazy on Discord, and I need to turn stream remote on. There we go. So now we're turning this back into the excess reactant, which we can then turn into grams of the excess reactant. All right, now we can just do the numbers. This is still 32 grams per mole. Still 1 to 1, and then this is still whatever it was, but I erased it, so I don't remember. HC2, H3O2, 60.05. All right, and I get 30.1 grams of oxygen. So what that means is that, oops, 30.2. I had to round in a different direction. So what this means is that from the extra vinegar that could have been made if I had used up all of the excess reactant, the extra stuff that was left over was 30.2 grams of oxygen. And that should be what's on the answer key. And let's go check the answer key. It's not. I have a mistake somewhere. Well, according to the answer key here, I have 4 sig figs for... Where did I lose a sig fig? Oh, from the subtraction. Yeah. So this, I think this answer is actually correct. 30.2 as opposed to 30.16. All right. Hopefully that answers your questions. So what I'm going to do now is I'm going to go put this screen back up, and we'll start the music again. We'll see if anybody has any more questions, and I'll just wait a little bit. And if nobody has any more questions, we'll call it a day. All right, so see you in a bit. there are any more questions, please post them in the chat. This will be a last call for questions. Alright, we're gonna wind this down. I didn't get any other questions, so I did want to thank everybody before I signed off for the last stream. If you are taking 161 next quarter, you're going to be hearing from me again in about 2 weeks. But until then, all that you have left to do is lab number 5 and the final exam, because I believe exam number 2 closed yesterday. I'm going to go check all the grades for that. That's going to be my next few days' task, is just getting all the grades entered and sorted and dealt with. So I want to thank everyone for coming to the review session. I hope that was useful. Thanks again for a wonderful quarter, and I will see you again in 161. Take care.